Uh, excuse me, sorry, the recording had stopped, and I was actually going on with the lecture. Let me pick up back where the recording has stopped. So, what I was saying is okay. So this is our influence diagram that we get. If we consider this as a 2D plane, and this is the x direction, and this is the y direction. In drawing the diagram, what we need is we need the coordinates of this point, and this point. Consider this as the origin. So from here we can see the coordinates here will be 0, 0.2. Here they will be b, I max. Here they will be 4b, 0. So what we do is first we draw this diagram. First we draw this diagram and then we superimpose our layers here. For example, if we have these layers. This is the second step. And the third step is we interpolate between the values of Imax to calculate the Imax at the center of each layer. So it is not necessary that our strata will be coinciding with these points exactly. There'll be one strata here, there'll be one strata here, there'll be one layer here. So it's not necessary. That is why whatever type of strata that we have, we will need to interpolate for the values of I. Here we need these Z and the other values. Okay, so let us go back to the PPT now. Okay, so we are talking about this diagram, and now let us calculate the coordinates of this diagram. We know that this is 0.2, 0, and let me copy the formula for our, let's see. Okay, so I was just now mentioning that at z is equivalent to 0, iz is 0.2, at z is equivalent to b, iz is I max, and at z is equivalent to 4b, iz is 0 again. So I max, let us calculate. So we calculated Q effective is QF minus gamma DF, which is QF is 150 and gamma DF is 18 times 1.5. So we will get 123 kilonewton per meter square. And sigma B is the effective stress at a depth B below the foundation. So the total depth will be the depth of foundation plus the width of breadth of footing. And this will be 12 times, no, 18. 18 into 1.5 plus 2, which is 63. So from this formula, 0.5 plus 0.1 under root Q effective by sigma B, we get I max is equal to 0.64. So we will get here 0.64 comma 2, and then this is at z is equal to 2, and this will be at 4v, which is 8 meters. 8, so this will be 0 comma 8. So this is our diagram. Now let us superimpose the layers of our foundation soil over this. We have a layer at too much. We have a layer at 0.5 meter. We have a layer at 2.5 meter, and we have a layer at 5 meter. Okay. And as I mentioned that we have to calculate the IZ values at the center of these layers. So we need it here. Let us do one thing. Let us hypothetically divide this layer here also. If we take the center of this layer, it will become an average of these two interpolations. It will be the same thing, but uh, just for showing, let us divide this layer here also. So we will have z values as uh, at 0, at 0.25, and here it will be, because this is 2 meter. Excuse me. Okay, so okay, this will be at 0.25. If this is 2 and then this is 1.5, this will be at 1.75, the center for this. This is 2, this is 0.5. This will be at 2.25. The center for this will be at, this is 2.5. Half of that is this will be at 3.75, and then this is 3 meter, this will be 1.5, this will be 6.5 meter. So we need to calculate the Iz values at these locations through interpolation. Let us do that right now. Let me remove all these. Okay, so let's draw a table here again. How many values we need? 1, 2, 1. At 0, do we need? No. 1, 2, 3, 4, 5 values. We need Iz, we need Es maybe. Let us take some more for our convenience. Okay, so this will be Z. This will be the Iz from interpolation. Okay, so let us fill this Z at 0.25, at 1.75, at 2.25, 3.75, 6.5. Okay, now let us interpolate for the first layer. Okay, the interpolation will be, we can write 0.64 minus 0.2, z is equivalent to 0. Let me write this again. Z is equivalent to 0.25, Iz is equivalent to 0.4, 0.2 plus 0.64 minus 0.2 over 2 into 0.25. Let us calculate this. This comes out to be 0.255 at Z equals 1.75, Iz equals 0.2 plus 0.64 minus 0.2 over 2 into 1.75, which will be equal to 0.585 at z equals 2.25. So we are coming here. So let us calculate on this limb. It will be Iz equals 0.64 minus 0.64 by 6 into 2.25 minus 2. So this comes out to be 0.6133. Same goes for z equals 3.75. We just need to replace this by 3.75 and further by 6.5. So Iz for these cases, let us calculate, will be 0.453, and here it will be 0.16. Is it the same that I had calculated yesterday? Uh, uh, so let us fill this table from the data that we have just obtained. Okay, so let us fill this table now. This is 0.255. This is 0.585. This is 0.6133, 0.453, 0.16.